Let's get going. Thanks everyone for coming. It's great to see such a good crowd. We appreciate you taking time out of your SIGGRAPH schedules to be here. My name is Neil Trevett. I'm the president of the Khronos group and chair of OpenCL. And we've put together a fun-packed 2 hours to bring you up to speed on the state of OpenCL and where it might be going in the future. So we have a set of esteemed speakers from Khronos, from AMD, from Graphic Remedy, from NVIDIA, from Intel. And we've ordered the schedule of events, so we're going to start out with a very brief overview from myself on Khronos and where OpenCL fits within the Khronos ecosystem. Then after, it's going to give us an overview of the spec, including the new OpenCL 1.1 spec, so it's just been out a few months. And then AMD, Graphic Remedy, Intel, and NVIDIA are going to talk about some of the specific projects and work that they're doing using OpenCL, so you can see actually OpenCL in action. Much more important than any of that, we've got prizes. So thanks to NVIDIA and ATI and Graphic Remedy, we have some Radeon boards, we have a Porto board here, and we have some licenses to Graphic Remedy debugger. So we're going to be rewarding the prizes on, those of you who've been to the OpenCL BOF will know this, so we're going to ask some trivia questions, and the first one with the right answer will get the prize. So pay attention, there will be a test later. So let's get going. Hopefully most of you are familiar with the Khronos group. We're an open standards organization. We're open to any company who wishes to join. We have over 100 companies currently active in the Khronos group. There are around 14 different working groups looking after different open, royalty-free standard API and file format definitions. It includes Collada, OpenGL, GLES, OpenMax, and of course OpenCL. If any of this content that we're going to go through is of particular interest and you'd like a voice in how OpenCL and the other Khronos standards evolve, please do come talk to us about joining and getting involved. OpenCL in particular is what we're here to talk about today. Was born from the realization that there's an increasingly interesting overlap between CPUs and GPUs. CPUs are becoming more, have always been programmable, and they're becoming more parallel. GPUs have always been parallel, and they're becoming more programmable. And so the kind of meeting and the overlap is an area where we'd like to develop a single programming framework to enable people to write heterogeneous parallel programs to make use of all the parallel compute resources in the system. And that's the mission that OpenCL has. In fact, it was such a strong need in the industry that when Apple first proposed OpenCL, it was just 6 months later, after many sleepless nights, that the working group managed to launch OpenCL 1.0, a complete specification of on the website. I think that's probably a world record for an open standard being set from the starting gun to an upload to a public server. There's been a lot of interest in implementing OpenCL since then. In 2009, there are multiple performance implementations, shipping on multiple OSs, multiple vendors. Khronos, we define performance tests as well as a specification. So if you see the OpenCL logo on an implementation, it means that that implementation has passed some fairly rigorous performance testing procedures. Back in June, we launched OpenCL 1.1. Turned out to be an 18-month cadence between OpenCL 1.0 and OpenCL 1.1. That was a point of carefully considered cadence. We didn't want to move too quickly because moving too fast when we just launched 1.0 would be disruptive to people just beginning to get into the standard and using it in real applications. But we want also to keep the momentum of the standard moving forward. So 18 months seemed like a good frequency to hit, and we'll probably hit roughly the equivalent frequency going forward with updates to the specification. So the OpenCL working group is a subset of the larger Khronos working group. It's good we have quite diverse industry participation. Processor vendors, there's system OEMs, middleware vendors, tools vendors, and some application developers too. So we have a good, rich perspectives as we create the specification. Apple did make the initial proposal and is very active in the working group, and they're serving as a specification editor. So before I hand over to Aki to sort of get into the details of the spec, I just want to kind of put the OpenCL into the broad perspective of some of the other Khronos APIs that the group is working on. A lot of people are wanting to do visual computing applications that mix graphics and compute together. We deliberately took the decision to make OpenCL a standalone compute-only solution rather than trying to put the compute within the context of the graphics pipeline. I think that's serving OpenCL in good stead. There are a lot of compute-only applications making use of OpenCL for that reason. When you do want to mix graphics and video, we define quite close interop between OpenCL and OpenGL. OpenCL and OpenCL have been able to swap buffers and data for some time, and as that will highlight, now we can share events to make that interop even more efficient. Not a lot of people might realize that OpenCL 1.0, 1.1 has an embedded profile within the specification itself. So we probably don't need an OpenCL ES, because the ES for mobile and embedded devices is already built into the spec from the get-go. And as we go forward, I think we'll see OpenCL beginning to interop with the Khronos ecosystem of mobile APIs, the OpenGL ES, the Max, and EGL, which is kind of the communication hub for many of the mobile APIs in many systems.